Hey guys, so I'm going to start by saying if you did not watch the video from last week about how to do trig using your calculator, that I highly recommend that you stop this video and go back and watch that one first. We're going to use what we did in that video and with that assignment last week in order to do the problems this week, okay? Some of you may be wondering, why are we doing trigonometry? I'm not taking trig, I'm taking geometry, right? Well, geometry is where trig is based. Trig is based off of right triangles. And so we're going to just scratch the surface. This is the very basics of trig, sort of its beginnings, so that should you come across this in another math class down the line, hey, you already have seen a little piece of it, okay? So anytime we are working with what are known as the three main trig functions, sine, cosine, and tangent, okay, they're abbreviated using those first three letters that are on those calculator buttons that we were using last week, okay? Every time you use one of those, they have a very particular setup, okay? So if you look at my screen right now, you see the three words, sine, cosine, and tangent. You see their abbreviations, and you see a symbol next to them, looks kind of like a zero with a line through it. That's the symbol for theta. Really, all that symbol is representing is an angle. If you look at the picture, you can see that same symbol in this bottom right angle of my right triangle, okay? So what this is saying is it will always be whichever one of the three trig functions you need to use with the angle measure. And then each one of them equal a fraction. That fraction is made up of two sides of your right triangle. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? When you look at a right triangle, we should all understand at this point that wherever your right angle is, if you go across, that's always going to be your hypotenuse, okay? So anytime you look at a right triangle, you should be able to identify the hypotenuse. To identify the opposite and the adjacent depends upon where the angle is. So in this picture, here's my angle. So if I go across, that's my opposite. Right next to it, that's the adjacent side. If the angle moves, then the opposite and the adjacent switch. So the opposite and adjacent are completely based off the location of the angle inside the triangle that you're going to work with, okay? The idea is you won't have all of the information. You will only have one angle, not both of them, to worry about. So you'll be able to identify which angle you're supposed to use, okay? This information that's on this slide, these setups are all on your formula sheet if you happen to have your yellow formula sheets with you. So that can be something that you can sort of pull out for reference. Otherwise, this might be the type of slide, hey, snap a picture of it or screenshot it, and then you have this information sort of as a handy pull up. There is a phrase that goes along with this. We often say soka toa, and I know that seems kind of strange, but if you're asked to remember the three trig functions on your own, this phrase soka toa is sort of a shortcut or a mnemonic for doing that. It says that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. This phrase is essentially giving you these three setups so that it's, again, something you could write on the top of a paper and have that sort of reminder, okay, which one is it? What goes on top? What goes on bottom? Okay. So what I want to do now is look at when you're given a picture, how do you use these trig functions in order to get to an answer? So what you're going to be presented with is a right triangle. with some information, okay? Instructions for any of these problems are always going to be the same. You want to round side lengths to the nearest tenth, angles to the nearest whole degree. So you also need to be identifying, what am I finding? Am I finding a side or am I finding an angle, right? My first suggestion with any of these type of problems is identify the three sides to your picture. So where's your hypotenuse, where's your opposite, and where's your adjacent side? Okay, so first thing I do is I look and I find my right angle. I go across from my right angle. Great, there's my hypotenuse. Okay, I find the angle inside the triangle. In this case, here's the 38. So I take my opposite, I go across. Here's my opposite side, and that means this side right next to it, that's my adjacent side. So I kind of abbreviated the words. You could just use an H, an O, and an A. That works too. But I do think it can help, especially at the beginning, to actually label the sides of your triangle. Okay. What's going to happen here is, out of these three sides, only two of them have information. So technically, I don't need this one. That one can go away. So how this helps me is, now the two that have information is how I'm going to decide which trig function I'm going to use. If this is opposite and adjacent, I need to decide which of the three I use. So I'm going to click back here and sort of steal my SOHCAHTOA and put it on this side. So if I am deciding which one to use, right? Bring those with me. Then which one uses opposite and adjacent? Well, opposite and adjacent, that's tangent, right? These other two use the hypotenuse, so I have to use tangent. Anytime you're doing a setup, okay, your setup is always going to be whatever word you're using. So in this case, we decided to use tangent with the angle. My angle here is 38 equals, and then you want to put in your fraction. So opposite is x over adjacent, which is 20. Okay. This is where what we did last week is going to come in handy, because before I do anything, I want to solve this for x. So what you should remember is, well, we're talking about this fraction. I'm going to multiply both sides by this 20, right? And if I multiply both sides by 20, that means now I'm looking at 20 times the tangent, of 38, and we're going to be equal to x. And so this is what needs entered through my calculator. So again, depending upon what calculator you're using, we just want to enter things carefully. I have that calculator that you can get from the Canvas page up. So I can type this in, right? I can put 20 tangent 38, and I'm getting 15.625, etc. This is a side of my triangle, and it says to round side lengths to the nearest tenth. So 15.6 is going to be my value for x. Okay, and that's how these problems will work. Trig is used to find missing side lengths or missing angle measures in right triangles. It's something we can use when we're given certain information. For example, I don't have a hypotenuse here, which is why Pythagorean theorem doesn't work. Okay, so we have to rely on what information do I have and what information can I use. Okay, so I'm actually going to stop this video. The next video is just going to be a lot more examples so that you have more to kind of look at.